In this video, we'll talk about polynomials. In this chapter, there's not much concept to know about, so we can directly start with the questions. So in the first questions, we're asked to find the possible expressions. Our hints are the y and x intercepts, but we have to start with the x intercepts first, because they're the roots of the expression. And factors are made of roots, and with the factors, their products is the expression itself. First, we'll put down our intersections. And to find our factors, we should make either side 0. So it is easier to move the numbers to the x parts. Okay, and here are our 3 factors. So our function will be their product. But the other hint is that our y-intercept is 24. And whenever we have y-intercept, we know the x value here is 0. So we can go ahead and test when x 0. So we know that it is 2 times -1 times -3. And this is +6. So we can see that the expression here we have is not the answer. To make a 6 here, we got 24, we should multiply the entire expression by 4. And now we'll get 24. So our final answer should have an additional 4 in front of all the factors. This is our final answer. In question 2, we're asked to find the value of a and b. And our 2 hints are 2x minus 3 is a factor, and when 1 is plugged into the derivative, its output is 4. Since this video is not about differentiation, I'll go ahead and finish the differentiation part. I'll plug 1 into the derivative. And by solving this equation, we'll get that a is 19. We now know that 2x minus 3 is a factor of this expression, meaning when it is plugged in, it will be a x-intercept, meaning y is 0. So we can go ahead and get the value of x when the output is 0. So now when we plug 3 over 2 into the equation, we'll get 0. We will now simplify the equation we have. Now 2 of our coefficients have a denominator of 4, so we can multiply the entire equation by 4 to eliminate them. And by using the a is 19 we got, we can calculate for b. So our final answer is A equals 19 and B equals 15. The second part of the question asks us to factorize the equation completely. So we have our A and B value from our previous question and our P of x. Now we'll plug in the A and B value we got. And beside that, we know, and other than that, 2x minus 3 is a factor of this polynomial. So when we perform long division by dividing this polynomial with this factor, we're going to get another polynomial. The first term of the second polynomial is 3x squared. So when it multiplies with 2x, it gives us 6x cubed. And the second term is minus 9x squared. Now 19 minus negative 9 is 28x squared. So the second term will be 14x. So their product is 28x squared. Now negative 52 minus negative 42, it is negative 10x. So our constant term will be negative 5. So their product is negative 10x. Right here is our second part of the polynomial. So our P of x can be written as 2x minus 3 multiplied with 3x squared plus 14x minus 5. Now we can further factorize the quadratic expression we have. So we know that it is the product of 2x minus 3, x plus 5, and 3x minus 1. This is our final answer. Question number 3, we're given 3 roots. It is x is 1 over 5, x is n, and x is n plus 1. Now we'll convert these roots into factors. Here comes our first one, then the second one, then the third one. So our P of x is a product of all of them in the factor form. Our next hint is the constant term of P of x is negative 2. To find the constant term or the y-intercept, we need to make x 0. So when we plug 0 into the equation, we can get negative 1 multiplied with negative n multiplied with negative n minus 1. And the output is negative 2. Now we'll treat negative 1 as a negative sign, and we'll distribute inside our brackets. Now n is positive, we'll multiply it with negative n minus 1, and distributing it will give us a quadratic equation. Now we'll go ahead and solve it. I'll factorize it. Here we have negative n plus 1 multiplied with n plus 2 is 0. So either these two cases will give us the answer. Now we get negative n is negative 1, or we can put a positive sign both sides, or n is negative 2. But the question mentioned that n is a negative integer, so the only valid number will be n's negative 2. Now we will plug our known root into our p of x. We're going to use 1 over 5 first. And the output will be 0 because it's a root. Because we have two denominators of 25, we can multiply the entire equation with 25. And here we have our first equation. The second part, we will use x is n, and the n we got is negative 2. And here we have our second equation. Right now we have a pair of simultaneous equations, or a system of equations. My approach will be making the a on top 2a by multiplying the entire equation by 2, so we can eliminate 2a. This will give us 2a plus 10b is 98, and 2a minus b is 21 the same. Now we'll subtract downward. Because the 2a will cancel, we only have 10b minus negative b and 98 minus 21 left. So it is 11b equals to 77. So b is 7. When we plug 7 back into our original equation, 2a minus the 7 we got is 21. 2a is 28, so a is 14. And we'll plug the a and b value into our original equation. P of x is 5x cubed, and we replace a with 14, so it is plus 14x squared, and replace b with 7, plus 7x minus 2. This is our final answer.